Hi, I'm Ed Thomas. I'm a business development manager for Loctite 3D printing. A lot of customers are familiar with the Loctite name for our adhesive product lines. I work for the 3D printing business unit within the same company. We manufacture photopolymers for industrial and commercial end-use applications for DLP and LCD style 3D printers.
And I'm Paul DeWys. I'm a sales engineer here at Forerunner 3D Printing. We're an additive manufacturer. We use a range of different printing technologies, but one of which is DLP 3D printing. And so we actually use a lot of Loctite's different resins and things like that. So we're here today to kind of tell you about a project that our two companies collaborated on using their resin and our printers to produce an end-use commercial product that we sell today. So here at Forerunner 3D Printing, we obviously print a lot of parts for different customers in different industries, but we also have a range of products that we've developed ourselves and we sell directly to consumers. We were bringing a new product to market and we wanted to run it on our Formlabs Form 4 equipment. And we needed a very specific type of resin that would work for both an end-use product, but also be fast and efficient to run on our machines. So I called up Ed and kind of explained to him what we were doing or attempting to do with this product, and he was able to offer us some suggestions as far as material goes. So the product that we're actually manufacturing with this resin on the Form 4 is called a Trimble. And it is a little basically alignment tool and measurement tool that carpenters use to set the reveal distance around windows and doors when they're installing trim. So this tool rattles around in the tool belt or the toolbox of carpenters out on a job site. We needed something that was going to be durable. We need to have a higher heat deflection temperature. You know, it might be sitting in the back of a work truck in Arizona in the dead of summer. So we needed something that's not going to warp and twist. We needed precision. It's a measurement tool, so the parts need to be accurate. Obviously, DLP machines are known for their accuracy, but the material also helps with that. And then we needed something that, you know, the material was reasonably cost. You know, we didn't want to go right to injection molding with this. It's a new product. You never know how a new product's going to perform in the market. So to go and spend $20,000 on an injection mold is kind of a big risk. Our business model is we like to start with printing, and we use printing to scale our products to the point of injection molding. So we needed just a very good, viable 3D printing material to make this out of. And Loctite had the perfect solution for us. Ed, do you mind telling them a little bit about the material you kind of directed us to?
Yeah, absolutely. So initially for an application like this, I mean, our go-to kind of general purpose, high accuracy, tough, rigid resin has been a resin called IND6843. It's kind of been the market leader for the past few years in the open source DLP and LCD printer space. And it is an excellent material and kind of become you know, our absolute workhorse of a product. But we actually had a new product coming onto the market called IND6845 that seemed to be an even better fit for this application. I know Paul mentioned he wanted to use his brand new Form 4 that now has an open material capability. And we'd started developing IND6845 as an improved variant of our IND3843, but it was designed to be a lot more effective for printing on LCD-based printers as opposed to projector-based printers. It also comes with an elevated heat deflection temperature now of up to 80 degrees C. So if these parts are, say, sitting in a car on a really hot summer day, the parts are going to be resistant to that. So given the requirements that Paul had given us for this project, IND6845 seemed like a really strong fit. With an elongation at break of over 40%, it's an incredibly tough and durable material while still having great aesthetics to rival that of an injection molded part.
And that was really important. Like you said, this is an end-use product that customers are actually going to be, you know, carrying around in a tool belt every single day. It's going to get beat on, it's going to get dropped, it's going to get left in hot trucks and work vans and things like that. So that was one of the big drivers of this. We didn't want a traditional DLP resin that, you know, is going to soften or warp. You know, it's a precision tool used for measurement and layout of door frames and windows and things like that. So, Ed got us lined up with this material. We ran our first batch of prototypes, gave them to our testers, and they were extremely happy with them. Parts held up great. And from a manufacturing standpoint, this resin is very cost effective, and we can run it on these Form 4 machines very quickly. So we can keep our production costs low while we still produce a really high quality part that a customer isn't going to get and instantly break in the first week that they're using it. So Ed, one of the requirements that I had for you when we were talking about different materials is, because this is a low volume production part, I needed something kind of easy to post process, something that could be efficient moving through our shop. So can you maybe talk a little bit about what you guys have done to make this material good from a post processing standpoint?
Yeah, absolutely. So just like previous materials that were robust, durable materials, we wanted a material that could print faster on LCD style printers, which this one does, but also one that can be more effectively post-processed. That is to say, easier to clean, easier to wash, and then easy to post-cure to deliver the final mechanical properties for that part.
Yeah. And I can say with this part in particular, we're actually able to stick this directly on the build platform of the Form 4. So there's not actually any supports on this part that have to be sanded off. So our workflow is we literally print these parts directly on the platform. That platform gets taken out of the machine and washed. And then once that platform has been washed, we pop the parts off of the platform, and then they go into a UV curing chamber where we do the final UV post cure to bring them to full hardness and strength. So Ed, are there any other characteristics of this material that you want to kind of let people know about that's important to maybe customers outside the United States?
Yeah, absolutely. So obviously Loctite and Henkel it's a global company, and many of our customers are based obviously outside the United States, especially Europe. And one big notable change for this material is that we are moving away from the photo initiator known as TPO, which I'm not a specialist on kind of European regulation, but it looks like that material will likely become restricted in Europe in the future, or possibly become restricted in Europe in the future. And to make sure that this material is accessible to European users and meeting current and future standards and regulations, this material is free of TPO.
So one of the things that's really exciting us about Loctite's commitment to the DLP space is they have a wide range of materials, and they're steadily onboarding those materials onto the Formlabs Form 4 platform. So when you have an open materials license on your machine, these guys are bringing more and more of their portfolio over that you can run. So, right now we've got this material, but I know these guys are working in their tech center on bringing elastomers, high temp materials, ESD materials, other types of rigid and durable materials. So there's all kinds of cool innovations that you guys are pulling over from your existing portfolio that'll be available on these Formlabs machines down the road. So that's something that's keeping us highly engaged with Loctite and working with these guys. And then also you can look forward to a lot more of kind of our different testing videos. We're working on figuring out, the pull-out force for brass inserts. We're looking at different durability tests, especially in the elastomers. We're looking at how those can be leveraged for Class A safe nesting, things like that. So there's going to be a lot of exciting things coming from Loctite and from Forerunner down the road as more of these materials become available on the Formlabs platform.